All right, in section 2.3, we're going to look at lines. And what we have here are some items to identify from a line. One is the slope, which the slope of a line is the measure of steepness of a line. And we'll talk about that here shortly. The y-intercept of the line is where the line, or in any graph for that matter, crosses the y-axis. For the y-intercept, the x-coordinate is 0. So when we talk about a point, we have two coordinates, x and y. For the y-intercept, the x is 0. The x-intercept of a line is where the line crosses the x-axis. And for that, the y-coordinate is 0. So let's first look at finding the slope of a line. Your slope is what we call rise over run. It's a measure on a line. So if we think of the line looking something like this, the way we measure how steep it is through a series of vertical versus horizontal movements from one point to the other on the line. The vertical movement is your rise. The horizontal movement is your run. And pretty much when we talk about the rise, it's the change in the y-coordinate. So it's really subtracting from one y to the other. The run is your change in your x-coordinate. Now m is the symbol for slope. And so what we have for slope is we can either physically count the rise over the run, or we can use the formula to where we take the difference in the y-coordinates, place that over the difference in the x-coordinates. So these little subscripts here, 2 and 1, refer to one point and the second point. So this would be your y-coordinates from the second point minus the first. Same thing for the x's. So just make sure when you're using the formula, if you're picking a y from one point, you got to pick the x from the same point. You can't interchange those. But it doesn't matter which point you consider your first point or your second point. So let's look at the three ways we can calculate the slope. One is from a line on a graph. Second way, we can do it from 2 points, and the third way is from an equation. So if I'm looking at the slope from the line, if you think about picking 2 points, I can look here, and this is my easiest one to go through. You don't always have to do the axes. It's just in this case, it's easier. And if I want to do my slope, I do my rise, which means I go down 3 and to the right 4. So my slope is down 3, right 4. Well, in math, down is negative and right is positive. So my slope for that line is negative 3/4. Now, it wouldn't have mattered which point we chose to start from, because if I chose to start from this one, it would be up 3 and left 4. So up 3, left 4 is 3 over negative 4, which is still negative 3/4 for my slope. So it doesn't matter. You just have to make sure that your up and down movements are in your numerator, your right and left movements are in your denominator, and you also have to pay attention to the signs. Okay, so let's move on now, and let's look at finding the slope of a line that passes through the points 1, 2, and 5, -3. So here I'm going to use my formula where I take my difference in my y-coordinates, put them over the difference in my x-coordinates. And if you look up here, it doesn't matter which one you choose for your first or second, but if I choose a y from this one, then that x has to come from the same point So I take my difference in my y's, y2 minus y1 over x2 minus x1. Watch your signs. So I get negative 5/4. Here in example 3, we're going to use the formula again, and we have various lines going through the same point. The point we have in common each time is 2, 3. So let's look at finding the slope here. Again, difference in my y's over the difference in my x's. So this is negative 2 minus 3 over negative 1 minus 2. Watch your signs here. So that's negative 5 over negative 3, which is 5/3. Now this slope overall is positive. So we identified this as positive slope. And positive slope, we always know the line, what I call, goes uphill. So it increases as you move left to right on the graph. Down here, we do it again. So I get negative 1 minus 3 over 3 minus 2, which is negative 4 over 1, which is negative 4. And this here is what we call negative slope, which means the line decreases as we move left to right on the graph. The biggest thing here, you got to watch your signs. That's the most troubling part of anything we do in math, is paying attention to our signs. So let's look up here to line 3, and again, I'm using the same formula. And this time I take my difference in my y's over my difference in my x's, which is 0 over 3, which is just 0. So this is 0 slope, which is a horizontal line. For the fourth line, I'm going to take my difference in my y's over my difference in my x's again, and I get 2 divided by 0 to where 0 is in the denominator. So this here is undefined slope, and this means that this would be a vertical line. So just because it has undefined slope does not mean we can't graph it. So your 0 slope is a horizontal line. Your undefined slope is a vertical line. So that's your 4 types of slope. And if you think about it, I mean, it's got to be one of these 4. The line's either going to go uphill, downhill, flat, or vertical. And there's ways you can tell if it's a horizontal line, your y coordinates are the same. Vertical line, your x coordinates are the same. So just try to pay attention to that, as we study these items. All right, the third way to find slope is if we're given an equation. So if your equation is in the form y equals mx plus b, that means it's solved for y. It can't be 2y equals something. It's got to be y equals something. We call this slope-intercept form. So when an equation is in this form, we say that m is the slope and b is the y-intercept. So for this equation here, 3x minus 5, the slope is 3, the y-intercept is 0, negative 5. If we want to find the slope and we're given an equation like this, we have to solve for y. So that means I have to get y by itself on one side. So in order to do that, I'm going to subtract 3x from both sides, which gives me negative 5y is 9 minus 3x. Reorder these terms so my x term can be first. Now divide both sides by negative 5. And when I do that, I can use the distributive property, and I can distribute this negative 5 to both terms here. Negative over negative becomes positive 3/5, and positive divided by negative is negative. So my slope is 3/5, and my y-intercept is 0, negative 9/5. So just watch your signs. That's usually the case. So that's the 3 ways to find the slope. You can always do it from a graph. You can do it given 2 points. Or if you're given an equation, you just have to solve it for y. Put it in the proper form and identify your slope. All right, the second item we talked about being able to identify from a graph is the y-intercept. And if the equation is not in slope-intercept form, then you need to do this. If it's in slope-intercept form, you already know it because, again, your y-intercept would be b. So this is not the same as solving an equation for y. I have students get that confused all the time. Finding the y-intercept is where we choose 0 for x, substitute the 0 in for the x, and then find what the y value is. So try not to get that confused. So down here, if I want to find the y-intercept, I let x equal 0, which gives me minus 5y is 10. Divide both sides by negative 5. Again, watch your signs here. And so y is negative 2. And so this is just exactly what you do when you create a table of values for points. You let x or y be any number you want to, find the other, and then you have a point to plot. So just make sure that you put that in point form so you don't get confused between what's the x-intercept and what's the y-intercept. Because if I want to use that same equation to find the x-intercept, I can. So when we want to find the x-intercept, again, that's where the graph crosses the x-axis. We choose the 0 for the y, we substitute it in for y, and then we find out what x is. So in this case, I let my y be 0. I get 3x equals 10, divide by 3. So x is 10/3. And so my x-intercept would be 10/3, 0. So just look at the difference here. X-intercept, the y is 0. The y-intercept, the x is 0. Try not to get that confused. All right, so that's how we can find the slope, y-intercept, x-intercept. Now let's look at, well, how do we graph? So you've got 2 methods to graph that I think are the best. One, you can find the intercepts. The other is using 1 point in the slope. So let's say I do have this equation here, and I would probably choose to find the intercepts for this one simply because both variables are on the same side of the equal sign. Makes it easier to do. And both of these divide into 6 evenly with no remainder. So let's go first with the y-intercept. If you think about it, you can make a little table of values here. So I can let x be 0. Substitute it, divide by -3. And so y is -2. Watch your signs. Okay? No different than what we did finding points. Anytime you're just finding specific points. Here, you want the x to be 0, and 0, -2 on your graph is right there. Don't get them backwards. Look, it has a y on it. Y-intercept. Y-intercept. The x-intercept is going to go on this axis. I see students get that backwards all the time. So don't let that be you. Next one is the x-intercept. Whoops. So for this one, I let y equal 0. And a lot of times you can do this in your head. You can just look at the equation. So that goes away. Divide by 2 to get x is 3. So here are my points right there. 0, -2, 3, 0. 3, 0 goes right there. And then I draw the line. All right, let's look at the second method on how we can graph. Here is using 1 point in the slope. So in order to use this method, we must put the equation in slope-intercept form. So that means we need to solve the equation for y, not the y-intercept. Solve the equation for y. So I subtract 2x from both sides. Reorder my terms. Watch your signs here. Divide both sides by -3. Distribute that -3. Simplify to get 2/3 x minus 2. Okay, you just have to watch your signs. All right, so given that, I know my slope is 2/3. I know my y-intercept is 0, -2. So I'm going to plot 0, -2. And then go up 2, right 3, to get your second point. So you plot the y-intercept, you use your rise over run, up 2, right 3. So I plot 0, -2, up 2, right 3. Uh-oh. Did I make a sign mistake somewhere? Oh, I made it on the other one. Duh. Right, 3. That's been a long weekend. All right, so there's the correct graph. First one, I tell y'all to watch your signs. 0, -2 is down here. So my bad there. My bad there. So that first graph should look like that. I'm surprised y'all were screaming at that y'all are screaming at the TV or at the screen wherever you're watching this going, hey, that's negative 2. I'm trying to write and talk, and it's been a long weekend. A lot of snowing. So sorry about that, but these graphs should look the same. But anyway, getting back down here, you plot your y-intercept up to right 3. All right, so that's your 2 ways to graph. So you can always find your intercepts, or you can use your slope and an intercept. Now we also have a vertical and horizontal lines. Vertical line is where your slope is undefined. Horizontal line is where your slope is 0. But you can also determine the slopes based on the type of equation you have. So in this equation, we have x is 3. Well, there's no way to find a y because there is no y for that equation. So what I normally just tell students to do, when x is 3, that just means x is always 3. You need 2 points to draw a line. Go 3, 0 and 3, 1. And that's how you won't mess up. Okay? You know, all the time I see vertical lines like drawn on these axes. There should be nothing drawn on these axes unless there's a 0 in there. So if you're given a regular number, you go to that number, because I'm telling you right here, x is 3. Go to where x is 3, find 2 points, and then draw it. That way you won't mess it up. The same thing kind of goes for your horizontal lines. Okay? Y is negative 3. So therefore, I can do the same thing with my XY table. Y is always negative 3, and I can just choose any 2 x's I want to. So I've got 0, negative 3, 1, negative 3, and that allows me to draw the line correctly. So you got to do what you feel you need to do, you know, to be successful. Okay, whatever you need to do. Whatever helps you get things right. All right, so that's kind of graphing. So you've got your 2 methods to graph, either finding intercepts or slope and y-intercept, or and the vertical and horizontal lines, special lines. Now we're going to look at, well, how do we come up with these equations? You know, how do we come up with these equations of lines? Well, just remember, each line on a graph has an equation that defines it, and we can find the equation of a line provided we know 1 point on the line and the slope. So you have to have at least those 2 items, because then there's no way to define what the equation would be. So once we have this information, we can use what's called the point-slope form of the equation of a line. A little different than slope-intercept form, but it will provide the same answer. So here's your point. That's what these x1s and y1s stand for. Those are your coordinates of your point. M is your slope. This y and this x do not need numbers. So this is what we use if we want to find the equation of a line. So let's look at an example. So I've got my point, I've got my slope, and what I know is that x1 is 1, y1 is 2, m is 4. I write down this formula, the point-slope formula, substitute in, and then solve for y. So I distribute, always distribute first before you start moving numbers over. Add my 2 to both sides. And so what I end up with is y is 4x minus 2. So I still have my slope, which is what I have anyway, and I have my y-intercept. Okay, now the next example, we want the equation of a horizontal line containing the point 3, 2. Well, remember, horizontal line, your slope is 0. So I can still use my point slope formula, but you'll notice something happening after we substitute. Y minus 2 is 0 times x minus 3. And what happens here is the entire right side becomes 0. Add 2 to both sides. And so I get y equals 2. But remember, in a horizontal line, the y coordinate is always the same. So that could have been the other way. You could have looked at this one and gotten the answer correctly. All right, moving on down to example 12. We want to find the equation of the line through these 2 points. So this time, remember, to find the equation of the line, you need the slope and a point. I don't have the slope, so we've got to find the slope first. Once we find the slope, we can use either point to find the equation. So I'm going to use my slope formula. Remember, difference in my y's, so -4 minus 2. And be careful here with your signs, because this is 1 minus -1, which actually turns into 1 plus 1. So I end up getting -3 as my slope. Now I have the slope. I can use either point to finish the equation. So let's just say we use the first point. Write down my point slope form and substitute. Y minus 2 is -3 times x minus the -1. So here comes that double negative again. So before you do anything, you need to make that x plus 1. Don't multiply yet. Always do inside parentheses. Simplify inside those parentheses first. Now I can distribute that -3. Add my 2 to both sides. And so y is -3x minus 1. So just watch your signs. Here's a biggie. Do not try to skip too many things at once. Make this x plus 1. Watch these double negatives on either side of your equation. Let's do another one. Here again, you're given 2 points. Find the slope first. So I'm finding the difference in my y's over the difference in my x's. So it's 5 minus 3 over -4 minus 2, which is 2 over -6, which is -1/3. Okay, you're not always going to get whole numbers. Sometimes you're going to get some fractions. Don't panic. It's okay. Just follow the steps. So I've got my slope. I'll go ahead and use one of the 2 points. So now we're going to substitute. Again, we write down our formula. Y minus 3 is negative 1/3 times x minus 2. Go ahead and distribute that negative 1/3. Just multiply negative 1/3 times the x. Negative 1/3 times negative 2 is positive 2/3. Okay, when we add this 3 to both sides, what happens is you get the negative 1/3 x. Well, anytime you have a whole number plus a fraction, it just becomes a mixed number, 3 2/3. If you want to make that an improper fraction, 3 times 3 is 9 plus 2 is 11/3. Okay, so it's not that bad. You know, don't give up. Just again, watch all your signs and make sure that when you add and subtract, you combine them properly. You can always find a least common denominator here with the 3 if you want to, which would be 9/3. That's how you would get the 11/3. But you can also, when you're adding, just take the whole number plus the fraction. All right, the last example is one where you have some options here. Since I know the slope and the y-intercept, well, I know m is 3, and I know my point is 0, -2. But think about the mx plus b. It only works if you know the y-intercept. So you could simply just substitute like that because you have the slope and the y-intercept. If it's not the y-intercept, you can't substitute it in for b. Okay, so just try to keep that in mind. Just some things you may come across. And it gives you options. I mean, it does give you options. Last thing, are parallel and perpendicular lines. We'll talk about these more in class, but for right now, just remember that if you deal with parallel and perpendicular lines, parallel lines have the same slope. So in other words, slopes are equal. Perpendicular lines have slopes whose product is -1. So that's it. We'll pick this up in class when I see you again. So have a good day.